Chem 2, it's Mr. McKay. Hello. Balancing simple redox reactions. Everyone's fun thing to do. Here are 3 of them from your worksheet that you had about a week ago that will help you both with the test coming up and the redox titration lab. First one here is a case where sulfur is both oxidized and reduced. Sulfur going from -2 to 0, and sulfur going from +4 to 0. Don't need to do step 3 in this case. Remember, the oxidation number is a very important step up top here, but we don't need to do step 3, which is balance the elements because they're already balanced, so we can go straight to the electrons. Losing 2 on the top, gaining 4 on the bottom. Common multiple is 4, so we'll multiply through that top equation by 2. And now the tricky part with these simple ones is, again, knowing that this 2 goes with the sulfur compound that has the -2 oxidation number, so 2H2S. And then we have 2, let me drop over to here first. We have basically 1 sulfur in the +4 state still, so H2SO3 with a coefficient of 1. Now the interesting thing that happens on these sort of combo ones, sulfur is doing both things here, or at least it's being reduced and oxidized to zeros. So I have to add the 2 plus the 1 here to get me 3 total. That's probably the one wrinkle on these. The other wrinkle that happens a lot in these is you have to clean up at the end. The water comes along for the ride. There's 6 hydrogens over here and 3 oxygens, so there's a 3 in front of that. And that should do it. There's the first balanced equation. The next one, we have basically sulfur being oxidized from +4 to sulfur +6. We have iodine being reduced from a +5 to a -1. Everything else is sort of coming along for the ride. Again, don't have to do step 3. Should think about it, but don't have to do it. Elements are balanced. Need to look at electrons. 2 electrons being lost on the top, and 6 electrons being gained in the reduction step. Common multiple 6. So again, we only have to multiply through 1 of the half reactions. And now we do the same thing we just did in the last problem, just bring all this stuff down. So we have a 3 in front of the sulfur with the +4 oxidation state. We have a 6 in front of the iodine in the +5 oxidation state. I take that back. We have only a 1 in front of the iodine in the +5 oxidation because that was just 6 electrons. So we didn't need to multiply through the reduction. So that's just KiO3 here. Up top, we have 3 in front of the sulfur compound with the +6. And we should have really just 1 in front of the compound there. So really, 2 easy ones so far until we get to this one. This one looks a little crazy and a couple strange things happen, but bottom line is the oxidation is chloride going to chlorine. And the reduction is the chromium, in this case hexavalent chromium, going to trivalent chromium. This, now we have to be careful with this too, and we do need to get 2 chlorines on the left there so we have the same elements on either side. Now we can look at balancing electrons. So in this case, we have 2 electrons total being lost, and we have 3 electrons total being gained. Common multiple is 6. So that's going to be a 3. Multiply 3 by 2. This one might be beneficial to multiply out, but I'm not going to do that for the sake of time in the video. We do know that the 6 electrons will have to cancel out. And start multiplying through. Now this one can get a little bit crazy because initially we're going to do this, and you'll see why I'm going to have to change some things. At this point there's a 6 in front of that compound because of the 3 times 2 here. There's a 3 in front of the Cl2 compound. Again, because of this 3 in front over here. Now we look at the bottom reduction. There's a 2 in front of the compound that has the Cr plus 6. However, shouldn't say in front, there's just 2 chromiums total there. Well, up here, since we didn't deal with that subscript 2 at the beginning, we don't need to put a 2 in front because really this, the 2 represents the amount of chromiums right there. So we're just going to go ahead and bring across what's already written. Now we can look at the chromium plus 3 on this side. There's two of those. But we haven't really dealt at this point at all, because the oxidations didn't change for these, with the KCl or the water. So this is a balance by inspection. So you get a little bit of an interesting thing happening here with the sort of cleanup step at the end with these guys. I know that I have 2 potassiums over here, so I do need a 2 in front of that, just balancing by inspection. And now I need to add up all my chlorines. I have 6 plus 6 more plus 2 more down here. That's 14. So even though we would love to keep that as 6, that's not reality. There's actually 14. And now we can start looking at our hydrogens and our oxygens, which usually is that water step at the end. So there's 14 hydrogens there, which means I need a 7 in front of that water. That gives me 7 oxygens. Well, fortunately, yay, the oxygens work out on that side. And if I inspect all the rest, it really should be okay. 2 potassiums on the left, 2 potassiums on the right. 2 chromiums on the left, 2 chromiums over here on the right-hand side. We already checked everything else. Difficult, but doable. Hope that helps. Good luck on your test.